All right, I'm just going to do a summary of all the things that we really should be able to do at this point. So when we're in the entire unit of acceleration, this is kind of everything we should be able to identify and look at. So we've been talking about three graphs. We've got a position time graph, and so I will draw a position time graph here. And I will draw it like so, and I'll make it weird. All right. So that's xt. We also have a velocity time graph, like so. And we also have an acceleration time graph, like so. All right, so I guess I'll do some weird colors. Let's pick some fun colors. Purple, yeah, let's go class colors. All right, so if I was to look at this graph, there's a bunch of things I should be able to understand, and I'm just going to start with just drawing a totally random velocity time graph. I'll just do this. There we go. There's my velocity time graph. Just kind of pick that out of nowhere. Okay, so there's certain things we should be able to identify off of that graph. So let's start with that because I think that's the one that we're going to be using the most. That's the one that I believe is the most beneficial, personally, at least. So let's go. Let's throw some red in here. All right, so first of all, we can read this directly, okay? Read directly. Now what that means is if I read it directly, I can say, hey, right here, my initial velocity is a negative value, okay? And then I can say, hey, my final velocity here is a positive value. So my initial velocity is a negative value, my final velocity is a positive value. I can just read this thing directly and I can say, hey, at this time, I have a certain velocity. So you can say at time t, the v is blank. Okay, you kind of fill in the blanks there. Now, also from that, you get speed, because if you know velocity, then you can find the speed. So therefore, you can say, hey, then I know the speed because this is the number. All right, so let's just say this is negative 10 meters per second. Then, let's just, a lot of colors today. Then this 10, that's my speed. All right. There's something else we know, and that is that this right here, this minus, the plus or minus, tells direction. So not only can we get speed from this, but we can also get direction. So what that means is that man, I'm just flashing with the colors today. All right, so that means that everything on this side, these are all positive velocities. So these are all moving in the positive direction. So if it's ever above here, it's positive. Everything down here, these are all negative velocities, so these are all negative directions. And then this is 0. So there's a lot of information you can get just by looking at it. Okay? Now, we can get more information, and I'll go back to black, I guess. So we can read it directly. We can also look at the slope. All right? Because the slope tells acceleration. And the reason why slope tells acceleration is because slope is your change in y over your change in x. Uh-oh, what did I do? What did I do? Oh no, oh no. Well, that'll be interesting in the take. I refuse to quit though. So, slope tells acceleration, because acceleration is change in y over change in x. And in this case, we have, that means change in velocity over change in time. So, therefore, we have acceleration. So the slope tells acceleration. So therefore, if I look at this slope, this entire slope, there's only one slope. And the entire time, it's a positive slope. So you have a positive slope. In fact, I should say we have one positive slope. So what that means is that we have one positive acceleration. Okay? So we can get that information off of this bad boy. So we really don't get a lot of information off the acceleration time graph except, hey, how is its velocity changing over time? So if we look at the velocity time graph, we get acceleration by looking at the slope. Now there's one last thing. Yes, this is why I said this is like the most important one, because there's even more stuff off of here. So let's go to a different color. I haven't used yellow. Who would use yellow to write with? I guess I'll go back to green. Okay, like my primaries, I guess. So the last thing is we can look at the area. All right, area tells, two L's and tells displacement. And the reason why area tells displacement, if you remember, we originally, for our constant velocity unit, we said that velocity is equal to displacement over time. And if I rearrange this, I can multiply both sides by time and say, well, that means displacement is equal to velocity times time. If you look at the area, it was usually like a rectangle. Well, that's the base is time, the height is velocity. So that means the area will tell us what my displacement is. And again, when I say area, it's always between the line and 0. So this shaded region right here. All right, so that would be the area. It's always between the line and 0. So that's another piece of information that we can use to help get a better understanding of our position time graph. All right, so that's everything that the velocity time graph can tell us. So now let's look at the position time graph. And so let's see, if I do this, I'm going to draw this. So I might as well just walk through how to do that, just double checking our understanding. Let's go back to Poiple. All right, so I'm going to read this directly. My initial velocity is something negative. So that means that my initial slope has to be something negative. So wherever I start, it has to be negative. I could technically start anywhere, because remember, this does not tell you where you start. Okay, it just tells you how your position is changing. So I just chose to start there for funsies. Then as time passes, okay, so time will drag us out, then we are going to end up having a velocity that is becoming 0. So I'd have a flat line. Now where do I have the flat line? Well, this entire displacement was negative, because again, we're looking at our area, so we have a negative area, so we have a negative displacement. So that means I have to go down, because if I'm going down, we'd have a negative displacement, moving towards, moving down basically. Not always towards 0, just moving down. So therefore, I have a negative displacement, so I'm just going to say, hey, why not end up right here? I don't know. I'm just, like I said, make this up as I go. Plus there's no numbers, so I can get away with anything. Then at the end, I know that my final velocity is positive, so I have to end up with a positive slope. Now, well, where is that? Because I could have a positive slope here, positive anywhere I wanted. Well, if I look at the area is positive, so therefore I have to be going back up. So I have a positive displacement. And so I'll end up somewhere back here, and it looks relatively symmetrical. Again, positive slope because positive velocity. And so I can do that. And so all the old things that we know from position time are still true. Okay, so I'll just quickly list those. I won't go too much into detail. But again, we can read directly. And when we do that, we get the position. All right, so you can have your initial position, you can have your final position. And then if you do some math, you can also then calculate displacement, because that equals your final position. Ah, no, that's your initial, Samansky. You thought too far ahead. So that's your final position minus your initial position. A big mistake students start making is if I throw them a position time graph, like, oh, it says find displacement. They say, oh, it's the area. No, that's on a velocity time graph, so don't make that mistake. All right, so this is the equation for displacement. So if you read it directly, you can get this. We still know that slope is velocity. And again, we talked about this from velocity. We can get speed from the number. We can get direction from the plus or minus, and things like that. So in order to get those things, then the new element is drawing tangent lines, as I mentioned earlier, just to double check. So again, just to refresh, here my tangent line has a slope of 0, so we have a velocity of 0. Here I have a positive slope on my tangent line, so I have a positive velocity. And here I have a negative tangent line with a negative slope, so I have a negative velocity. So I can kind of track my motion by drawing those tangent lines and looking at those slopes. So this is everything that you really should know at this point. I know it seems like a lot. That's why we're just kind of go piece by piece by piece. And this is stuff you have to just know. All right. So if this is not memorized, work on that. Because if you don't have the fundamentals memorized, the application is going to be really hard. So hope that just reminds you of all the things that we now have in our toolbox. And happy physics.